Means we're putting back together and we're fixing without parts from Bugatti, and we've already done and accomplished what we were told couldn't be done, which is give us confidence.
Imagine spending nearly $2 million on a wrecked Bugatti, knowing the finished car could be worth several $1,000,000, and then discovering that one of its supposedly exclusive parts carries the same part number as something found in a much cheaper Audi. That is exactly the kind of discovery that can make even the most experienced car enthusiast stop and ask one simple question. What is really hiding inside a $6 million hypercar? The Bugatti Chiron Sport is not an ordinary car. It is one of the rarest and most extreme road cars ever built, with only 60 examples made. It has an 8.0-liter quad-turbocharged W16 engine, around 1,500 horsepower, a carbon fiber structure, and a price that places it far outside the world of normal cars. Every detail is designed to create the feeling that you are looking at something almost impossible to replace. But one badly damaged Chiron ended up in a very different situation. Instead of sitting safely inside a Bugatti facility in France, it was sitting in pieces inside a workshop in Miami. The front of the car had been destroyed in a major crash. The airbags had deployed, the front bodywork was badly damaged, and the vehicle had been written off by insurance. At first, the story looked simple. This was a very expensive hypercar that needed an even more expensive repair. But then the owner decided not to give up. Alex Gonzalez, known online as FXA Alex G, bought the damaged Chiron back from a Copart auction for just under $1.9 million after fees. Most people would have looked at the wreck and seen a financial nightmare. Gonzalez saw something different. He saw a car that might still have a second life. To make that happen, he brought in British mechanic and YouTube creator Matt Armstrong, a man known for taking badly damaged and written-off performance cars and rebuilding them in front of millions of viewers. This time, however, the challenge was on another level. A normal damaged supercar is one thing. A crashed Bugatti Chiron Sport is something completely different. The car uses advanced carbon fiber construction, a huge W16 engine, for turbochargers, complex electronics, and countless specialized components. Even small mistakes could turn into massive problems. There was also another major obstacle. According to the story documented in the series, the damaged Bugatti's VIN had been restricted within the official parts network, meaning Armstrong and Gonzalez could not simply call a Bugatti dealer and order every replacement component they needed. That changed the entire project. Instead of rebuilding the car with a factory parts list, the team had to find other solutions. They had to inspect damaged components, study part numbers, fabricate certain pieces, rebuild others, and work out how to bring the car back to life without relying on the normal factory repair process. And somewhere during that process came the discovery that turned a complicated rebuild into a much bigger conversation about expensive cars and shared automotive technology. Armstrong and his team began checking the numbers stamped on components inside the Chiron. One of those discoveries involved the airbags. The part numbers reportedly matched components used in other vehicles, including the Audi A3. Suddenly, the story was no longer simply about repairing a crashed Bugatti. It became a question about what people really expect when they spend millions on a car. Does a $6 million hypercar need every single component to be unique? Or is it perfectly reasonable for a manufacturer to use a proven component from another vehicle when it meets the required safety and engineering standards? The answer is more complicated than the dramatic headlines suggest. But that is exactly what makes the Chiron rebuild so fascinating. Behind the carbon fiber, leather, horsepower, and enormous price tag is a machine built using the same basic principles that guide the rest of the automotive industry. Parts have to be tested. Systems have to be reliable. Engineers have to make practical decisions. And when Armstrong began pulling the car apart, he gave viewers something they almost never get to see. A close look at what actually sits beneath the badge of one of the world's most expensive cars. The story became even more unbelievable when the damage was finally understood. The Chiron Sport had not suffered the kind of small accident that could be fixed by replacing a bumper, painting a few panels, and sending the car back to its owner. The front of the hypercar had been badly crushed. The airbags had deployed, the headlights and body panels were damaged, and the famous Bugatti horseshoe grille was destroyed. Insurance estimates put the repair cost at around $1.7 million, a number so large that it was easier to understand why the vehicle had been considered a total loss. For most cars, a repair bill of that size would make no financial sense. But this was not most cars. This was one of only 60 Chiron purse sports ever produced. Even as a wreck, the car still represented an enormous amount of money, and more importantly, it represented something that could not simply be replaced by buying another one. There were only a limited number in existence, and each one had its own history. When the damaged Chiron went to auction, the story could have ended there. Someone could have bought it for parts, removed the engine, transmission, carbon fiber structure, wheels, interior, and other valuable components, and slowly sold them to collectors. Instead, Gonzalez decided to take an enormous risk. He went back to the auction and bought his own wrecked Bugatti. After fees, the purchase came to just under $1.9 million. Think about that decision for a moment. He was not buying a beautiful Chiron sitting in perfect condition. He was buying a damaged machine that needed millions of dollars worth of work and had already been judged by insurance as too expensive to repair. There was no guarantee that the car would ever return to the road. There was no simple factory repair plan waiting in the background. And there was no normal parts shopping trip that could solve the problem. Yet Gonzalez had a plan. He wanted the car rebuilt, and he wanted the entire process documented. That is where Matt Armstrong entered the story. Armstrong had already built a reputation for taking cars that looked finished and giving them another chance. His videos work because viewers do not simply watch a mechanic replace parts. They watch a problem develop, grow, and eventually get solved. The audience sees the damaged car at the beginning, then follows every difficult step toward the final startup. With the Bugatti, however, the pressure was much higher. Every component was expensive. Every mistake could cost a huge amount of money. And the technical complexity of the Chiron meant that even experienced mechanics could not treat it like an ordinary project car. Armstrong and his team therefore had to approach the vehicle almost like investigators. Before fixing anything, they needed to understand exactly what they had. They began taking the car apart piece by piece, documenting damage and identifying components. The deeper they went, the more obvious it became that the biggest challenge was not simply finding replacement panels. The Chiron is built around a carbon fiber monocoque, meaning the main structural section of the car is a major part of what makes the vehicle so light and strong. When a structure like that is involved in a serious accident, you cannot simply look at the outside and decide that everything is fine underneath. The team needed to separate sections, inspect the structure, understand what had happened during the crash, and determine what could be repaired and what would have to be replaced. According to the story presented in the rebuild, Bugatti had offered an official repair route, including sending the car to its facilities in France. Earlier estimates had reportedly reached around $1.7 million before being revised to a lower figure in the range of $600,000 to $700,000. Even the lower number was enormous, and the owner did not want to take that route. Instead, the project moved forward in Miami. This decision created a completely different kind of challenge. Without simply ordering every required component through Bugatti's official network, Armstrong's team had to think like fabricators, engineers, mechanics, and researchers at the same time. They had to work out what could be repaired, what could be rebuilt, and what could be sourced elsewhere. That is also where the controversy surrounding the car began to grow. The project was not only showing people how difficult it is to repair a modern hypercar, it was also showing viewers how dependent such a car can be on its manufacturer's parts and support network. If a manufacturer controls access to specialized components, diagnostic information, and repair procedures, an owner can have a very expensive machine sitting in a workshop while still being unable to get the pieces needed to make it work. In the case of his Chiron, that problem became especially important because the car's VIN was reportedly restricted from the normal parts supply network. Whether someone views that as a reasonable safety measure or as an unfair restriction depends on how they look at the issue. From the manufacturer's perspective, a damaged hypercar presents serious safety concerns. From the owner's perspective, however, spending millions on a vehicle creates an expectation of ownership and control. That tension became one of the most interesting parts of the entire rebuild. And Armstrong's decision to continue anyway meant that every new component could become another puzzle. The question was no longer simply whether the Bugatti could be repaired, The question was how much of a car could actually be rebuilt outside the official factory system. As the team began working through that puzzle, they discovered that not everything inside a $6 million Bugatti was necessarily designed only for a Bugatti. Some components appeared to have connections to other vehicles within the wider Volkswagen Group world. That discovery would soon turn the attention of millions of viewers toward a small detail most people would never think to check: the part number stamped onto the component itself. And that tiny number would become one of the biggest talking points of the entire project. Then came the moment that changed the story from a difficult rebuild into a much bigger mystery. As Armstrong and his team worked through the damaged Chiron, they were not only looking at what was broken, they were also looking closely at the numbers stamped onto the components. In a normal repair, a part number might seem like nothing more than a boring code used by mechanics and parts departments. But on a car like the Chiron Sport, that small number can tell a very different story. It can reveal where a component came from, whether it is shared with another vehicle, and sometimes how manufacturers organize their parts across different brands. The team began cataloging the components that needed attention, and eventually their investigation reached the airbags. This was where the discovery became especially interesting. According to the rebuild story, the knee airbags fitted inside the Chiron Sport carried part numbers that matched components used in the Audi A3. Suddenly, a car worth millions was connected through a simple part number to a vehicle from a completely different price category. The comparison was almost impossible to ignore. The Chiron Sport was built as an extreme hypercar with a huge W16 engine, carbon fiber construction, advanced aerodynamics, and a price that could reach several $million. The Audi A3, by comparison, is a much more ordinary road car designed for a completely different group of customers. So when viewers heard that the same part number could appear in both vehicles, the reaction was immediate. It sounded strange. Why would a company known for producing one of the most exclusive cars in the world use a component that could also appear in a much more affordable vehicle? But this is where the story needs to be understood carefully. A shared part number does not automatically mean that the two cars are identical in every respect. Modern car companies use common parts for many reasons. Safety components, electrical systems, sensors, switches, connectors, and other pieces can be developed once and then used across several vehicles if engineers determine that the component meets the required standards. Bugatti is also part of the Volkswagen Group, while Audi belongs to the same larger automotive family. That means there is already a connection between the companies. From an engineering and business point of view, sharing proven components can make sense. Developing a completely new component for every single model would take huge amounts of time and money, and it would not necessarily make the final product better. The important question is therefore not simply whether the part came from another Volkswagen Group vehicle. The more interesting question is whether the component performs the job required of it inside the Bugatti. An airbag is not impressive because its housing has a special logo. It is important because it must deploy correctly when the vehicle's safety systems command it to do so. Its performance depends on the complete safety system around it, including sensors, control units, deployment settings, vehicle structure, and calibration. In other words, seeing a familiar part number does not automatically prove that Bugatti cut corners. It does, however, reveal something that many buyers may not expect. Even the most expensive cars in the world can contain components that have relationships with more affordable vehicles. That is the part of the story that makes Armstrong's discovery so fascinating. It does not necessarily expose a secret scandal, but it does pull back the curtain on how modern automotive engineering really works. The same thing happened with another airbag discussed during the rebuild. Armstrong reportedly checked the part number on the steering wheel airbag and found a connection to the Aston Martin DB11. Again, the discovery created an interesting contrast. The Bugatti was presented to the world as one of the ultimate expressions of automotive engineering, yet some of the safety hardware inside it appear to share its origins with components used elsewhere in the industry. For viewers, that can completely change the way they look at expensive cars. A luxury vehicle does not necessarily become special because every single bolt, sensor, airbag, or electrical connector was invented specifically for that model. Its value can come from the total package, the engineering, materials, performance, design, production limits, craftsmanship, testing, and brand history. A shared component can still be perfectly suitable for an expensive vehicle. In fact, using a proven part can sometimes be a smarter engineering decision than creating an entirely new one simply to make the component look exclusive. But the discovery became controversial because of a huge difference in the prices of the vehicles involved. When viewers hear that a component associated with a relatively affordable Audi can also appear inside a multi-million-dollar Bugatti, they naturally start asking whether they are paying for engineering or simply paying for the badge. That question is understandable, but it also needs context. The cost of a car is never determined by the price of every individual component added together. A hypercar's price includes research and development, testing, production methods, carbon fiber work, specialized machinery, low-volume manufacturing, engineering teams, quality control, assembly, design, performance development, and the enormous cost of creating a vehicle that only a tiny number of customers will ever own. The fact that one component is shared does not erase all of those other costs. Still, the discovery matters because it challenges a common idea about ultra-luxury cars. Many people imagine that a vehicle costing millions must be completely different from every cheaper vehicle in every possible way. The reality is more practical. Manufacturers build complicated machines by combining unique engineering with proven technology. Some parts may be highly specialized and designed specifically for one model, while others may be shared because there is no good reason to reinvent them. Armstrong's rebuild gave ordinary viewers a rare opportunity to see that reality instead of simply hearing about it in a brochure. And that is why the part number became more important than the physical part itself. The real discovery was not necessarily that Bugatti had used a cheaper airbag. The real discovery was that underneath the exotic bodywork, a modern hypercar can still follow many of the same engineering rules used throughout the automotive. The airbag discovery may have created the biggest online debate, but the real test was still sitting underneath the damaged bodywork. A part number could tell the team where a component came from, but it could not repair a carbon fiber chassis, rebuild a damaged cooling system, or make a crashed W16 engine run again. The deeper Armstrong and his team went into the Chiron, the more they realized that this project would require far more than normal mechanical skill. They were dealing with a car built around a carbon fiber monocoque, a structure that forms the main foundation of the vehicle. Everything else depends on that structure being strong, straight, and correctly positioned. After a serious crash, even a small problem in the chassis can create major consequences later. That meant the team could not simply start bolting new body panels onto the car and hope for the best. They had to understand the damage from the inside out. The front section needed to be separated so the structure could be inspected properly, and this was another point where the project became unusual. The rebuild story presented the process as something that normally requires specialized equipment and trained technicians. But Armstrong and his father approached the job with the tools available in their workshop. Instead of relying on a massive factory setup, they used a 2-post lift and a simple wheeled base to support the structure while they worked. It sounds almost too simple for a vehicle of this value. A multi-million-dollar hypercar was being carefully separated in a workshop using equipment that would look ordinary compared with the machinery inside a factory. Yet the process moved forward. Once the sections were separated, the team could finally see what they were working with. The carbon fiber tub had damage, but according to the rebuild account, much of it appeared reparable rather than requiring the entire structure to be replaced. That was a major turning point. If the main structure had been beyond repair, the project could have become financially impossible. Instead, the team had a path forward. The gearbox also needed careful attention. Earlier reports had suggested serious damage, and every viewer following the project understood how important that component was. A Chiron gearbox is not something you can casually replace with a part from a normal performance car. It is one of the most specialized systems in the vehicle, and a problem there could stop the rebuild completely. The team therefore had to inspect everything carefully before deciding what could stay and what needed attention. Then they reached another huge challenge, the cooling system. The Chiron is famous for its enormous power, but producing around 1,500 horsepower also creates enormous amounts of heat. According to the rebuild account, the car uses 10 radiators to manage the temperatures created by its W16 engine and related systems. Several of those radiators have been damaged in the crash. Normally, the obvious solution would be to order replacements through the manufacturer. But this was not a normal situation. The team was working around the restrictions that had made the project so difficult from the beginning. So they had to find another answer. This is where Bob Ree from the machine shop became an important part of the story. Instead of simply giving up when replacement radiators were difficult to source, the team explored the possibility of rebuilding them. The original tanks could be used while new cores were installed. According to the story, the core material itself cost only a small fraction of what someone might expect when looking at a vehicle worth millions. That does not mean the finished radiator was simply a cheap replacement. The real value came from the knowledge, labor, measurements, fabrication, and testing needed to make the components suitable for the car. This is an important distinction. A raw material may be inexpensive, but turning that material into a working component for a 1,500 horsepower hypercar is a completely different task. Then came the front crash bar. This was not a cosmetic part. It was an important structural component designed to help manage energy during an impact and protect the vehicle's structure. The damaged original could not simply be treated like a scratched body panel. A replacement had to fit correctly and connect to the chassis in the right places. According to the rebuild account, Bob spent around 60 hours fabricating a replacement crash bar. There was no simple trip to a local parts store where the team could pick one up. They had to work from measurements and the information available to them. The process showed something that is easy to forget when looking at modern supercars. Advanced manufacturing does not eliminate basic craftsmanship. Even the world's most complicated cars still depend on people who can measure accurately, cut material, shape it, weld it, and understand how different pieces need to work together. The Chiron may have been designed using advanced engineering